Hey, good morning guys, it's Mr. Sprague again. We're talking about further explorations of vertex form, y equals a times x minus h squared plus k. Today we're going to be looking at key features of a quadratic function using game cards so that we can look for patterns in the axis of symmetry, and I'll know I have it when I can find the axis of symmetry in two different ways. So without graphing, let's state the vertex for each of the following equations. For this first one, remember we have that vertex form a times x minus h squared plus k. I'll rewrite that down here. And so we know our vertex is h comma k, which means in this problem it is going to be positive 5 and positive 3. In the next problem, it's not quite in vertex form. We don't see that parentheses, but we can adjust it so that we get this x minus 0 squared minus 2.5. And therefore our vertex hk equals 0 comma negative 2.5. And lastly, for letter C, we can add a plus 0 at the end, and we can see that our hk is negative 4 comma 0. Again, pay attention to this negative sign and this positive sign. The x-coordinate of the vertex, if it's a positive in the parentheses, it turns out to be a negative when you list the vertex. Okay, number 2, we're going to write a quadratic equation who has the given vertex. In all these problems, it doesn't matter what our a value is, because that does not affect the vertex. All we're doing is we are replacing. Let me just actually copy and paste this for all three of them. Scratch that. Okay, so we have x minus h squared plus k. So I'm going to replace this h with a 1.9, and we're going to replace this k with a negative 4. Letter B, I'm going to have a times x minus 0 squared plus 100, or if you want to get rid of the 0, you can just say x squared plus 100. And lastly, I have y equals a times x plus 2 squared plus 3 over 2. And all these a values can be whatever you want. It can be negative 4, it can be positive 6, it can be 3 over 9, it can be whatever you want. It doesn't affect the actual vertex. Number 3, it says do game cards. Obviously, I'm just going to go through this without using the game cards. We have to find the equation in standard form, list the vertex, the y-intercept, and graph them. It says your graph should be a rough sketch, but at least 3 key points. I said this in class about a week ago, where when you're graphing a parabola, you want to have at least 3 points, one of them being the vertex. So the equation in standard form, in order for us to do that, let's go ahead and do box method. So I have x minus 2, x minus 2, x squared minus 2x minus 2x plus 4. Collecting my like terms, I get x squared minus 4x plus 4. And then let's not forget about this minus 2. So my final vertex form is x squared minus 4x plus 2. My vertex is given from the vertex form. That's going to be positive 2 comma negative 2. And the y-intercept is always going to be that constant term from standard form. So my y-intercept is going to be 0 comma 2. So now we have enough information to graph this. We have our vertex is 2, negative 2. We know the concavity is upwards because our a term is positive. I know my y-intercept is 0 comma 2. Given the fact that we know the vertex, I'm going to go ahead and draw a line of symmetry that goes through it. And using that property of symmetry and the y-intercept, I know I'll have another point 2 units away from the axis of symmetry. And there we go, I have 3 points. And I know my concavity is upwards. And there's my sketch. Letter B, let's do box method. I'm also going to demonstrate a shortcut after we do box method. This gives us x squared plus 10x plus 25, and then we still have a minus 1 from the original problem. So this standard form is x squared plus 10x plus 24. Our vertex we know is -5, -1 from the vertex form, and the y-intercept is 0, 24. Okay, to graph this y-intercept, that's going to be a little bit difficult because we don't quite have 24 on the y-axis, but I could do the vertex. That's going to be over here. We know the concavity is upwards, and the y-intercept as 24 is going to be way up here. So it's going to be something like that, way off the chart. I'll go ahead and skip down to the last one so we can get to the rest of the lesson. Instead of a box method, I'm going to go over a shortcut, a plus b squared, that equals a squared plus 2ab plus b squared. So in this situation, I have a is x and b is 1. And so the shortcut tells me that I will have x squared plus 2 times x times 1 plus 1 squared. And this simplifies to x squared plus 2x plus 1. And if I did box method to verify that, I would get the same answer. I would get x plus 1, x plus 1, x squared plus x plus 1. This gives me x squared plus 2x plus 1. If you notice, they match. And then we also have this plus 2 at the end, so let's not forget that. So our final answer for standard form is x squared plus 2x plus 3. Our vertex is going to be -1, 2, and our y-intercept is 0, 3. So here's our y-intercept, here is our vertex, and if we know our vertex, we also know our axis of symmetry. And by that property of symmetry, I know that there's going to be another point on this side of the vertex. Again, this concavity is upwards, it's positive, so I have my 3 points, I have my vertex, and I can draw my parabola. Number 4 says for each equation from exercise 3, we need to determine the axis of symmetry and then draw the axis of symmetry on each of the graphs. We already did that in ours. We drew the axis of symmetry, but this time, let's just go ahead and list it. Let's do it. So in number 5, I'll skip this for now. I'll move on to number 5. 5 says, Scott says that his tutor gave him the equation x equals -b over 2a to find the axis of symmetry of a quadratic function. The a and b values are found when the equation is in standard form, f of x equals ax squared plus bx plus c. We need to use the standard form of the equation from exercise 3 to verify the axis of symmetry. So in letter A, let's go ahead and list out our A, B, and C values. A is going to be the coefficient of x squared, that's going to be a -1. And B is going to be the coefficient of x, which is 2. Therefore, negative b over 2a equals -2 over 2 times 1, which simplifies to -2 over 2, which equals -1. What this x value means is that is where our axis of symmetry is, which means this is the x-coordinate of our vertex. I'll do a couple more examples. I'm not going to go through all of them. Letter B, I have a equals 1, b equals 10. Therefore, negative b over 2a equals -10 over 2, which is -5. And letter C, I have this time a is -1, b is -4. So negative b over 2a equals -4 over 2 times -1, which simplifies to 4 over -2, which is -2. In the image below, two of the equations have an axis of symmetry at x equals 0. I'll highlight that right here. What part of the equation tells you that any equation of the form ax squared will have an axis of symmetry of x equals 0? Well, if we want to talk about the axis of symmetry, we can compare that to the vertex. Let's talk about vertex form. Right now we're dealing with y equals x squared and y equals 3x squared. We're getting these equations right here. So if I rewrite this in vertex form, I'll get y equals x minus 0 squared plus 0. And this 0 right here tells me that my axis of symmetry is 0. Similar concept over here. 3 times x minus 0 squared plus 0. This is going to be that axis of symmetry. Okay. What is the axis of symmetry for the third quadratic function? Well, for our quadratic function right now, this is in standard form. So let's go ahead and try to change that to vertex form. This one is a little bit more difficult than going the other way around. Okay. I'm going to use Desmos to demonstrate this. So I have x squared minus 5x plus 30. Okay, and I encourage you guys to use Desmos at home as well. So the axis of symmetry is going to be that vertical line that goes through the vertex, x equals 2.5. There we go. We also could have looked down here at our units. We know that this axis symmetry is right between 2 and 3, so that's going to be 2.5. So the summary, the standard form of a quadratic function is f of x equals ax squared plus bx plus c. The vertex form of a quadratic equation is f of x equals a times x minus h squared plus k. Both forms give specific information about the parabola formed, and you can use the equation x equals negative b over 2a with the standard form to find the axis of symmetry. This negative b over 2a is also helpful in finding the vertex, which we will get to in another lesson.